Hi everybody, this is Mrs. Peachy from your WCA biology class, and today we are going to be looking at the portfolio Analyzing Digestion, which is in Unit 4, Lesson 5 of your second semester biology class. This portfolio I am really paring down quite a bit, so it's very important that you follow the directions that are given on my website and make sure to only include what you absolutely need to do, otherwise you're going to end up doing way more than I'm requiring. So I would first advise you to go to my website, which of course the link to that website is found on my message boards. Click on Biology B, go down to Unit 4, or actually, where is that thing? Here we go, Analyzing Digestion. It's under Portfolio Recordings. There is a rubric here. You can click on it. And it says you're basically going to be doing just one of these two things here. There's two experiments to pick from. I'm only going to have you do the experiment and fill in a chart like this. That's it. And include a data table and conclusion. And then you'll have all the points necessary. So your two possible experiments are, does amylase break down starch? Include the questions, hypothesis, a list of materials, and step-by-step procedure for your experiment. Also identify the control and independent and dependent variables in your experiment. So you're going to design the experiment, but you're also going to do the experiment and collect data in a data table, graph it, and come up with a conclusion. The other question is, do acidic conditions deactivate amylase? So is amylase work if it's acidic? So that's, your stomach is very acidic, right? Again, design the experiment and then do it. So either or, but not both. So let me give you some ideas here. Amylase is found in your spit. It's one of the places that produces it. Your saliva will have amylase in it. Amylase is an enzyme that speeds up the decomposition of carbohydrates or starch molecules. Breaks it up into smaller chunks, which are simple sugars, like glucose. Okay? So when you are spitting on something that's made of starch, it should change its composition from a starch to a sugar. So we have something that we've used this school year that actually is able to detect the presence of starch, and that is iodine. Iodine detects the presence of starch. If I use a dropper of iodine and I put it on something that has high in starch, like bread, cereal, crackers, something like that, it should turn a purple or a purplish black color. If it does not have starch in it, it will just be brown. It will not change color because its normal color is brown, okay? So think about a situation where you could measure qualitatively the presence of starch in something like a cracker, for example, before it's exposed to saliva, and then measure the starch after it's exposed to saliva. What could you do? What experiment could you run where you tested the presence of starch before saliva, the presence of starch after saliva? Okay? Definitely don't want to put any kind of iodine in your mouth. So think outside of that situation. You're not putting iodine in your mouth. Okay, so that's definitely a no. But anything else where you're trying to be able to figure out that situation might be helpful. The second test is, does acidic conditions deactivate amylase? We know that if you chew a cracker up, for example, it should turn from starch to sugar. There's experiments out there that have you chew until the cracker starts to taste sweet. It's not a very good experiment because you're not actually measuring the presence of starch in any way, shape, or form except using your taste buds, which can be kind of deceptive, really. So what if you think that maybe acid is going to make amylase not work? So if I have a cracker and I put, let's say, something acidic like lemon juice or vinegar on that cracker, and then I pour some amylase on there, maybe not amylase, but maybe some saliva, and I pour it on there, My hypothesis might be that the iodine will still be brown because the amylase was deactivated by the vinegar. Maybe instead of pouring them on separately, I can take my spit into a test tube, and then mix it with some vinegar and shake it up. And then put in a piece of cracker and measure for the presence of starch. And then do a second test tube where I only do saliva and cracker and no vinegar. And that would be your control. And then again, use the iodine to measure for the presence of starch. That's a possibility too. So there's some thoughts of thinking of how can I see if acid will deactivate, or in other words, make amylase not work. Remember, amylase's job is to cut up that starch into smaller segments, into sugars. Once you've done including your hypothesis, your list of materials, and a step-by-step procedure, including your control and independent and dependent variables, then also include the data table. Actually, what's great for this, guys, is doing pictures. If you can do photographs of what you've done, that actually works really well. You can take pictures with your phone and just upload them, say onto Google Photos or something like that, so that you can actually have those pictures there, or you can email them to yourself. And then you can include them into a PowerPoint. And basically, this is how you're going to be graded here. You will have 4 points for the data table and conclusion, and 1, 2, 3, 4, 5, 6 points for the rest of this, with a total of 10 points. That's all I'm requiring from you for this portfolio. I do not want you to do the other part, which has to do with the food pyramid and that kind of stuff. We're not going to be doing that. It's too much work for 10 points. So this is all you do need to do. If you have any questions or concerns, feel free to give me a call at extension 2204 or send me a webmail message. Have a great day.